Good afternoon, guys. All right, so moving along in our Math 30-1 course, the unit is trigonometry. So the way that we do trigonometry at our school, and I know it's not the same as in every other school. Some schools split it up into kind of two sections. We split it up into three sections. And we're following the way that our textbook follows it, like that. So they go chapter 4, 5, and 6. Our chapter 4 is what we call the unit circle. Chapter 5 is what we call trig functions, and chapter 6 is trig identity. So I know some schools kind of group these things a slightly different way. This is the way that we do it at our school. So the series of lessons over here are going to be for chapter 4 in the textbook, and then I'll just move on to chapter 5 and chapter 6 like that. So depending on where you're at, you may be doing these things in a slightly different order, but this is how we do it. So the first unit we're doing is what we call angular measure. So the explanation that I always like to give for this is that in physics class, or in chemistry class, you've learned of several different ways that you can measure temperature. So you can measure temperature in degrees Celsius, in degrees Fahrenheit, and in degrees Kelvin. Well, in math, we have two different ways that we can measure angles. Now, the first way you already know is in degrees. Okay, so it's just the 360 degrees is a full circle, so that means 180 is half a circle, 90 is a right angle, 45, and so you can just kind of break down and measure angles in degrees. Okay, now the new way is going to be what we call is the angle in radians, is how we do this. Now, for years in math class, we always say that make sure that your calculator is in degree mode, not in radian mode. Okay, so radian mode is just another way that we can measure angles in, and we're going to learn about that. So by definition, okay, 1 radian is equal to the sector angle formed when the arc length is equal to the radius of the circle. Okay, seems like a very, I'm going to say, intense definition over here, but let's tackle a few things. First of all, what's sector angle mean? So if you're looking at this diagram here, okay, where we have the green circle, and then we have a section or a sector of the circle, which is kind of drawn in black here. Okay, so the sector angle is going to be the angle measured from here to here, just this section over here. Okay, now what do we mean by arc length? An arc length, I'm going to describe this as a partial circumference. The circumference would be the distance all the way around the outside part of the circle. Well, an arc length is just going to be just the length from here to here, where this length, okay, is going to be the arc length of this sector angle over here. So by definition, 1 radian is equal to the sector angle formed when the arc length is equal to the radius. So in this diagram, my radius of the circle here is 1. If you look over here, the arc length, that means the distance along the edge of the circle from here to here, is also 1, because the length of this curved part of the circle is going to be 1. So if we go along the edge of the circle 1 radius, the angle formed is 1 radian. That's by definition. Okay, so if the radius is 1, if I go along a distance of 1 on the outside of the circle, this is 1 radian. Moving along, so in this diagram over here, I now have my radius is 1. I've now going an arc length of 2. That means this angle here is 2 radians. If my radius is 1, if I travel a distance along the sets over here where this guy is 3, that means this angle is 3 radians. Guys, I have a point here in a second here. If we have this guy over here where my radius is 1, if I travel an arc length all the way around like this, where this guy over here is an arc length of 6, that means this angle from here to here is 6 radians. Okay. Now this question is going to be a bit different here, where we're telling you the radius of the circle is 3, so it's not 1 anymore, but the bigger circle is going to be a radius of 3, and the radian, the arc length, so the sector angle is 2.5 radians. Well, what's this arc length going to be? Okay, that means that I've gone here, here, and then half. So that means this is 3, because this would be 1 radian from here to here. This would be another 3, so that's 2 radians. This would be another 3 here. And that means this one from here to here will be half of that, which is 1.5. Another way of doing this is going 3 times 2.5 gives us an answer of 7.5. Okay, and this is going to be what the arc length from here, 3 plus 3 plus 1.5, or 3 times 2.5 gives us an arc length of 7.5. All right, so over here, your arc length formula for a circle of radius r and arc length a, we have a equals r theta, where theta is measured in radians. Now, if you guys take a look at your formula sheet, like the Math 30 diploma formula sheet that you guys should have, you might see this formula. Okay, and hopefully you agree that this is the exact same formula. Okay, so if you just divide both sides by r, a over r equals your angle theta. Okay, now the thing is, this formula only works, so this is an angle over here, this has to be in radians. This formula does not work if this guy is in degrees. Okay, so if you look at this question over here, the arc length in the diagram below is 12.6, and you guys want to change this over here. Let's go to the nearest tenth of a radian. Okay, let's just type out there, my mistake. All right, arc length in diagram below is 12.6. So that means from here to here is 12.6. That is a. Our radius, look at the radius of the circle. Well, the radius is 6. That means r equals 6. So we have a equals r theta, or a over r equals theta. Our arc length is 12.6. Our radius is 6. 12.6 divided by 6 is 2.1. So that means this over here is 2.1 radians. Okay, that's how that guy works there. Example 3. Note that the circumference of a circle is given by the equation c equals 2 pi r. Another way of saying this is the circumference of a circle is equal to 2 pi radiuses. Okay, so what it means over here, if you go from here to here, and this is 1 radian here, that means I'm traveling 1 radius over here. Well, if I go all the way around the circle, the difference from here all the way around, sorry, terrible drawing there, but it's going to be 2 pi radiuses. So what we're trying to get at over here is that 360 degrees all the way around the circle is equal to 2 pi radians. So this is kind of the ratio that we're going to use throughout this course. And if I just divide both sides by 2, we got 180 equals pi radians. This is kind of the simplified version of this ratio here. All right, so example 4, fill out the unit circle in radians. We know that it's 0, so here's a unit circle. Okay, now first of all, what a unit circle means. The unit circle, we're going to study this more in topic 4.2 in the next lesson, is centered at 0, 0 with radius 1. We're going to talk about this more in the next section. All right, so what we talked before, 0 degrees is going to be 0 radians. Okay, we talked about that all the way around was 360 was 2 pi radians, therefore 180 is pi radians. The way we're going to do this next is that if 180 is pi, well, what's 90 going to be? Okay, well, 90 is half of 180, therefore half of pi is pi over 2. Next we're going to look at is 45 degrees. Okay, so 45 degrees is half of 90. That means this guy is going to be pi over 4, because pi over 4 is half of pi over 2. This is a quarter of pi. Next, I'm going to look at a little pattern here. If you look at this point, and this point, and this point, so these points going all the way around the circle, I hope you see that 45, 90, 135, 180, these guys are all 45 degrees apart. That means they're also pi over 4 apart. So that means if this guy is 1 pi over 4, this guy would be 2 pi over 4. Now 2 pi over 4 simplifies to pi over 2. That means this guy over here is going to be 3 pi over 4. This one here is going to be 4 pi over 4. 4 over 4 is the same thing as pi. Next we're going to have 5 pi over 4. Next we're going to have 6 pi over 4. 6 over 4 reduces to 3 pi over 2. And last one, we have 7 pi over 4. Okay, so all we're doing is if I'm counting up by 45, 45 plus 45 plus 45 plus 45, I could think of this as counting up by pi over 4. So pi over 4 plus pi over 4 will be 2 pi over 4, reduces to pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is the same thing as 2 pi over here. Okay, so far so good? All right, next we're going to look at 30 degrees. What pattern we're looking here is we're going to look at 180. And if you go 180 divided by 6, you get 30. So if 180 is pi, that means 30 should be pi over 6. Okay. Next thing I'm going to do, I'm just going to put little squares around these guys over here. And we're looking at another pattern here. And the pattern is, we're going to look at it in degrees first. If I go from this square to this square to this square, I'm always going up by 30. 30 plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 150, plus 30 is 180, plus 30, plus 30, plus 30, plus 30, plus 30. Well, if 30 is equal to pi over 6, it's the same thing as adding pi over 6 every time. That means this guy over here is going to be 2 pi over 6, which simplifies to pi over 3. This guy over here simplifies to 3 pi over 6, which simplifies to pi over 2. This is 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, we'll reduce these in a second, 10 pi over 6, last one is 11 pi over 6. If I was to go back to 360, which would be this point over here all the way around, that'll be 12 pi over 6, and 12 over 6 is the same thing as 2 pi. Now reducing these, 2 pi over 6 reduces to pi over 3. Sorry, I already did that right here. 3 pi over 6 reduces to pi over 2. 4 pi over 6 to 2 pi over 3. 5 pi over 6, 6 pi over 6 reduces to pi. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. Okay, so this is how we kind of fill out the unit circle in degrees. Now, in our next topic in 4.2, we're going to add coordinates to each one of these points as well, but we'll show you how to do that in the next section. Okay, so for this question over here, given that 180 equals pi radians, make the following conversions. Okay, now a couple things here. If I have 180 degrees equals pi, I can do two things. I can divide both sides by pi, and that means that 180 over pi should equal 1. Or if I have 180 equals pi, I can divide both sides by 180, and I get 1 equals pi over 180. Now the idea of this is we're going to look at either this fraction or this fraction. And for those of you guys who are in chemistry, this is very similar to what we do in unit conversions when you're doing like your stoichiometry stuff. Okay, so if I'm going from degrees into radians, that means I want to cancel out my degrees and be left with radians. That means I'm going to multiply by this guy, pi over 180 over here. So I'm going to go, let's do this off to the bottom here. 35 times pi over 180. Okay, now what it says over here, it says exact and then nearest tenth. Okay, now I'm going to do the nearest tenth first. For the nearest tenth one, I want to go on my calculator, 35 times pi divided by 180. Doing that on your calculator, we get equals 0.6. That means we have 0.6 radians, and that's what it's going to be to the nearest tenth. Okay. Now, if we want this one exact, it means we're going to leave it in terms of pi. So pi is an irrational number, and we're going to leave it as a symbol of pi. But what we can do is I can reduce this fraction over here. So what's 35 over 180 reduced to? If I just go divide by 5, you get 7 over 36. Okay. You can just go 35 divided by 180, and then go math frac on your calculator, and we get 7 pi over 180. So the pi didn't go anywhere. I just reduces this fraction over here by itself, and then we have to keep the pi in here as well. Okay, but 7 pi over, my mistake guys, sorry, 7 pi over 36, there we go. This is going to be the exact value over here. Moving forward, we have 415. So I want to multiply times pi over 180. 415 times pi over 180. I want to reduce this fraction here. I'm going to do this one on my calculator. So I go 415 divided by 180, math frac, gives me 83, over 36, okay? Now, rounding this one to the nearest tenth, so this step would be 415 times pi divided by 180. I'm just going to put this exactly like this in my calculator. 415 times pi divided by 180 equals 7.2 radians, like this. So exact value, leave it in terms of pi. Nearest tenth, 7.2. All right, 7 pi over 12 equals blank degrees. So similar in this case, I have a radian, but I want to have a degree. So what I want to do over here is I want to multiply times this guy over here instead. So 7 pi over 12, just going to do this work right here, 7 pi over 12 times 180 divided by pi. Now what do you see here? The pi's cancel out. So I have 7 over 12 times 180. Answer is 105 degrees. Okay. Now for the second one, it says to the nearest degree. That means we're going to have to round this guy, but we're going to do the same way. We have 5 pi over 17 times 180 over pi. The pi's cancel out. Same thing, 5 over 17 times 180 equals 53 degrees. And there's our answer rounded to the nearest degree. Okay, moving on. We have a definition here we'll call the angle in standard position. So an angle in standard position is an angle whose terminal arm is the positive x-axis and vertex is the origin. The terminal arm can be in any of the 4 quadrants. So what we mean by here, the terminal arm, okay, so terminal arm is the positive x-axis, is going to be this part here. So here's your, sorry, my mistake, guys, this is the initial arm over here. The terminal arm would be this guy over here. So in this case, this would be from here to here, my angle in standard position. Now it says the terminal arm can be any of the 4 quadrants. So here's what I mean by that. So if I say draw (110 degrees) in standard position, well, my initial arm would be this guy over here. Now if this was 90, so from here to here would be 90, I'd be doing like up like this, and that means from here to here would be 110 degrees, like that, okay? If I had to draw 200 degrees, well, here's my initial arm. Well, from here to here, this would be 180, so I have to go slightly past that, like this. And that would be this way over here is 200 degrees, okay? If I had to draw 300 degrees, that would be, here's my terminal arm. This would be 270, so 90, 180, 270. I'm going slightly past that. That means this angle here would be 300 degrees. Okay, so definition, another definition is something we call the coterminal angle. 2 angles are coterminal if they share the same terminal arm. So 40 and 400 are coterminal. So this is what we mean by that. If I draw, so what's an angle of 40 going to be? Well, that would just be starting here, up to here. That would be 40 degrees. Okay. Now, what would 400 be? You know, 400 is more than 360. That means we're going So 400 is really equal to 360 plus 40. Now, you see this plus 40 is the same as this 440. So how to draw this? I'd start here. I go around here. That's 360 plus the extra 40. You see how we end up in the same terminal arm over here, right? So 40 and 400 are definitely not the same angle, 40 and 400, but they end up in the same place. That's what we mean by coterminal angles. So for this one, example 6, list one positive and one negative coterminal angle. So for this one, I'm just going to go 125 plus 360 equals 485. So 485 is 1. Now, how do the negative one? I'm going to do the same thing, but I'm going to subtract 360. And I'll explain what a negative angle means in a second here. But 125 minus 360 equals negative 235 degrees. Yeah, so it'd be negative 235 degrees, like that. All right, so that's how this guy's going to work between this guy and this guy over here. Okay. All right, so the way negative angles work, if I said like draw negative 70 degrees, what would that look like? Well, normally, if this is my angle over here, I'd go in this direction over here, okay? But if I go from negative 70, I'm still starting here, but like negative 70 would be going down in this direction like this. So starting on my positive x-axis on my initial arm, going down, that's what a negative 70 degrees would look like. All right, for example 6, similar idea, except instead of adding 360, I'm going to add 2 pi. Okay, because 360 is the same thing as 2 pi in radians. Now, trick here is we're adding fractions. So I'm going to make this guy 2 pi over 1, and I'm going to multiply the top and the bottom by 4. And that gives me 5 pi over 4 plus 8 pi over 4 equals 13 pi over 4. If I do the same thing and subtract, we're going to get negative 3 pi over 4 like that. Okay, so there's your positive and your negative coterminal angle. Okay, example 7 says list all of the coterminal angles. Now, what we mean by this is how do you do this? I'm going to write this like this. So what this says...
Just a reminder, students, those of you in grade 10 that actually went to David Thompson Middle School, your yearbooks are available outside the school cafeteria right now. So David Thompson students from grade 10 that purchased yearbooks, head towards the cafeteria first. Thank you.
So what this means, 75 degrees plus 360n, where n, e, I. This stands for n is an element of the integers. So I stands for integers. So the way this works is like if n equals 1, then we have 75 plus 360 times 1 is 435 degrees. If n equals 2, it would be 75 plus 360 times 2. Okay, so that means I'm going around the circle twice from 75. That's going to equal 795 degrees, and so forth, or n equals 3. If n equals 0, because that's also an integer, I'd have 75 plus 360 times 0, which is just 75. That's just the first one we have over here. And if n equals negative 1, it would be 75 plus 360 times negative 1, which is 75 minus 360, which is negative 285, like this. Okay, so this is a way that we can generalize all of the coterminal angles for 75 degrees. 7 pi over 12, same idea. So we're going to have, except we're going to be in radians. So 7 pi over 12 plus 2 pi n, where n's an integer. Okay, so this is going to add all of the multiples of 2 pi, adding on to 7 pi over 12, and this is going to give us all of the coterminal angles. Okay, another definition, guys. A lot of definitions in this section. The principal angle is the smallest positive coterminal angle. Okay, So it has to be a positive but the smallest one. So if I go to 1200, what I can do here is I can subtract 360. And that's going to give me 840. Okay. Now I'm going to keep on going and keep subtracting 360. So 840 minus 360 is 460. And then 460 minus 360. Got a mistake. It's 480, not 460. 480. If I go 480 minus 360, I get 120. If I go 120 minus 360, I get negative 240. Okay. Now, you see here, negative 240 is a negative one. So therefore, the smallest coterminal is going to be 120. So it's going to be 120 degrees like that. So next one, 43 pi over 3. I'm going to do the same thing, except I'm going to subtract 2 pi, and 2 pi is the same thing as 6 pi over 3. So I'm going to subtract 6 pi over 3, and that gives me 37 pi over 3. And then I'm going to subtract 6 pi over 3 again, which gives me 31 pi over 3, minus 6 pi over 3 again is 25 pi over 3. And then I'm going to keep on going until I hit my smallest positive. And then 7 pi over 3 minus 6 pi over 3 equals pi over 3. And if I do one more, I'm going to get a negative number. So this pi over 3 is my principal angle. Okay.